How do you actually build the perfect engineer, ready to tackle the massive, complex challenges of our world? Yeah, that's the big question, right? It's not about just finding these people, it's about systematically building them from the ground up. So how do you design an education that guarantees a graduate is ready for anything the modern market can throw at them? I mean, it's a huge challenge, but believe it or not, someone has actually created a blueprint to answer it. And here it is. This is the blueprint we're talking about. It comes from Saudi Arabia's Education and Training Evaluation Commission. We'll just call them ETEC. And what they've done is create this incredibly comprehensive set of standards for an industrial engineering degree. For us, it's the perfect guide for this explainer because it lays out in really amazing detail how to construct the engineer of the future. Okay, so you might be thinking, why go to all this trouble? I mean, why create such a ridiculously detailed plan? Well, that brings us right to the first part of our blueprint, really understanding the grand challenge that engineering education is up against today. See, here's the core problem they're trying to solve. There's this gap, right? A gap between what you learn in a university classroom and the actual practical skills that industries and even entire nations are desperate for. So this whole blueprint is designed to close that gap, to make sure that every single graduate walks out the door with the knowledge and skills that are in high demand, not just now, but for years to come. Now this is where it gets really interesting. How they actually built this thing. This wasn't just some document cooked up in a boardroom. No way. It was put together using a super rigorous, global process to find the absolute best of the best. So ETEC used this really meticulous 5-step method. First, they basically scanned the entire globe for the best practices out there. Then they started moving from the big picture down to the tiniest details. They went from the general curriculum to specific knowledge areas, and finally all the way down to defining exactly what a student needs to be able to do for every single topic. It's this awesome top-down approach that, it just leaves nothing to chance. And this slide just shows you how smart their approach was. They didn't try to reinvent the wheel here. Instead, they benchmarked everything against the gold standards. We're talking about major accreditation bodies like ABET, professional societies, and, get this, the curriculum of world-leading universities like Georgia Tech, Stanford, and UC Berkeley. That's the foundation they built this on. All right, let's keep going and see how all of this stacks up. Because look, before you can build a specialist, you've got to build a rock-solid foundation. And this next part of the blueprint is all about that. It's the universal toolkit that every single engineer needs. I don't care what their focus is. And the blueprint builds this foundation into really distinct layers. First up, you have the essential knowledge units. Think of this as the absolute bedrock, right? Your math, like calculus and linear algebra, and your basic sciences, like physics and chemistry. Then, on top of that, they layer on the general knowledge units. These are the core engineering topics that every student has to master before they can even think about specializing. And from that solid foundation, you get these core abilities, what they call key learning outcomes, or KLOs. And what's so important here is that they go way beyond just the technical stuff. Of course, it's about solving complex engineering problems, but it's also about designing solutions while thinking about public safety, the economy, and the environment. It's about managing projects, communicating effectively, and, this one's huge, being a lifelong learner. Okay, so we've got that universal foundation laid. Now we can zoom in on the specifics. Let's get to the heart of this blueprint, the nitty-gritty components that really define an industrial engineer. This chart here, it's basically the DNA of an industrial engineering major. It's a really fascinating mix, but you can see that two areas totally stand out. They're like the twin pillars of the whole curriculum, each one taking up 24% of the focus. You've got operations research, that's all about optimizing complex systems, and quality engineering, which is about making sure everything works perfectly and reliably. Everything else kind of builds around those two big ideas. So, since operations research is one of the biggest pieces of the puzzle, we've got to ask, what in the world is it? I know, the name sounds kind of abstract, maybe a little intimidating, but trust me, what it does in the real world is incredibly concrete. Okay, to put it simply, operations research is the science of making better decisions. That's it. It uses really advanced math and analytical methods to look at super complex systems. Think of a global supply chain, a huge factory floor, or even a busy hospital, and it finds the single best, most efficient way to make that system work. So here's what that actually looks like in the real world, for you and me. An industrial engineer uses operations research to design the very supply chain that gets you a package delivered overnight. They use it to optimize a factory workflow to reduce waste. They use it to model complex systems to see what's going to happen. They even use it to figure out how to minimize your wait time at the hospital or the bank.
It's all about solving those network problems, like finding the absolute shortest route to make systems work better.
All right, so let's pull all these threads together. We've seen the big challenge, we've looked at the global methodology, the universal toolkit, and the specialized parts. So, what's the final product? What does the engineer who graduates from a program like this actually look like? Well, a graduate from a program built on this blueprint is basically a master of efficiency and improvement. These are people who can literally walk into a factory and redesign the layout to make it better. They can manage incredibly complex supply chains. They can use statistical methods to control and improve product quality. They can analyze the economic impact of big engineering decisions. And they can even design workplaces that are safe and efficient for people. That's that ergonomics piece. And you know, this brings us right back to the core mission stated at the very beginning of the document. The whole point of this incredibly detailed, globally benchmarked blueprint is to produce highly qualified professionals, people with the knowledge and skills that the market and the nation actually need. They're not just qualified on paper, they have the exact skills required to build, innovate, and lead in the real world.
It really is an impressive, super systematic approach to building talent. And it kind of leaves us with a final question for you. With the blueprint this detailed, if you had this kind of toolkit, what complex system would you want to design and improve?